Welcome to Study Loop.
This question gives us a boundary value problem, which is a second-order differential equation with two boundary conditions. It wants us to find the solution if any exists. To start off, we need to look at our equation y double prime plus 4y prime plus 20y equals 0. To generate the characteristic equation, as normal, we set y of t is equal to e to the rt, where r is some arbitrary number. Then y prime of t by the chain rule is equal to r e to the rt. Y double prime of t by the chain rule again is r squared e to the rt. So then plugging all three of these in, we get y double prime, which is r squared e to the rt, plus 4y prime, which is r e to the rt, plus 20y, which is e to the rt, is equal to 0. On this left-hand side, we can factor out e to the rt since it's in every term to get r squared plus 4r plus 20 equal to 0. So one of these two things on the left is going to be equal to 0. E is never 0. E to the rt is never 0 for any values of t. It's always going to be a positive number. So then we have to find the values of r for which r squared plus 4r plus 20 is equal to 0, the characteristic equation. So we'll have to use a quadratic formula because it does not appear to be an easy way to factor it. So we set r equal to -4 plus or minus the square root of 4 squared, which is 16 minus 4 times 1 times 20 over 2, which is equal to -4 plus or minus 16 minus 4 times 20 times 1, which is 80 over 2. We can see from this square root here, it's going to be negative, so we'll have auxiliary roots. This is equal to -4 plus or minus 16 minus 80 is -64 over 2, which is equal to -4 plus or minus I times the square root of 64, since the square root of -1 is equal to I over 2, equals -4 plus or minus 8I, square root of 64 is equal to 8 over 2, which is equal to -2 plus or minus 4I. Based on this, we can find our general solution using -2 and 4. Our general solution is going to be y of t is equal to a constant c1 e to the -2t cosine of 4t plus another constant c2 e to the -2t sine of 4t. Now we're going to have to plug in our initial conditions. Y of 0 is equal to y of 0 is equal to 1. Y of pi is equal to 2. So we'll find y of 0. This is going to be c1 e to the 0 cosine of 0. And then I would write out the second term, but we have sine here. And then sine of 0 is equal to 0. So no matter what these two are, we'll have a plus 0. So e to the 0 is equal to 1. Cosine of 0 is equal to 1. So y of 0 is equal to c1, which is equal to 1. So we have that c1 is equal to 1. So we have y of t is equal to e to the -2t cosine of 4t plus the constant c2 e to the -2t sine of 4t. So now what we're going to do is look at our second initial condition, which is y of pi is equal to 2. So we calculate y of pi equal to negative e to the -2 pi cosine of 4 pi plus c2 e to the -2 pi sine of 4 pi. So cosine and sine are both periodic with a period of 2 pi. That means that cosine of 4 pi is going to equal cosine of 2 pi, which is 1 by definition. Same with sine. Sine of 4 pi is equal to sine of 2 pi, which is then equal to 0 by definition. So then we have y of pi is equal to e to the -2 pi times 1, which is e to the -2 pi. But Our condition is that y of pi is equal to 2, and e to the negative 2 pi is not equal to 2. This means that we do not have any solutions which satisfy the equation and our boundary conditions. So that means we have no solutions.